Question says the electric field in region is given by E equals A upon x cube. Write a suitable unit for A and find the potential in the region, assuming the potential at infinity to be 0. So first of all, we are given with here electric field. So let's write here electric field E is equals to A upon x cube, correct? And it's along x-axis, right? This unit vector represents along x-axis. Now if this is electric field, they're asking what should be the unit of A. So what is the unit of electric field? We know unit of electric field is either Newton per coulomb, this is one of the unit, and another is volts per meter, right? So if it is Newton per coulomb, let's write here Newton per coulomb into x cube. X is in distance, meter, so meter cube. So this can be one of the unit, Newton meter cube per coulomb, or another can be volts per meter into meter cube, volts per meter square, volts into meter square, that's our unit of A. So these two units can be possible for A. Now question is saying find the potential in this region. To find potential, this is very important. If you are given with the potential, then electric field is what? Electric field is minus dV by dr, if you remember, correct? So if you want to find potential from electric field, how do we find it? V will be equals to minus integration. There is differentiation. If voltage is given, you differentiate it to get the field because it's a negative gradient, right? So if you are given with the field and you are asked with the potential, you have to integrate it, okay? Because both are opposite operations. So E into dr, right? Now what is our electric field in this? It is A upon x cube. So let's differentiate with respect to x only, because here we have a function of x only, right? So this will give you A is constant, taken out, integration of 1 by x cube dx. And what is 1 by x cube? 1 by x cube is nothing but x to the power minus 3 dx, right? And x to the power minus 3 is nothing but, how do we integrate? Let's remember our formula. Our basic formula for integration is integration of x to the power n dx will be equals to x to the power n plus 1 upon n plus 1, right? So let's apply it here. So this will give us V, let me write it here, V equals minus A, integration of x to the power minus 3, it will be x to the power minus 2 upon minus 2. How we got it? Minus 3 plus 1 upon minus 3 plus 1. So you will get potential is equals to, this minus will make it plus A upon 2x square, and it's a scalar quantity, no I cap, no j cap, anything, okay? So this is our first one. Question 2 says, 3 charges each equal to Q are placed at 3 corners of a square of side A. Find the electric field at the 4th corner, okay? So let me draw a square here, okay? So this is our square, let's say, okay? Let's assume this is our square. And 3 charges are there, each of magnitude Q, okay, are placed at the 3 corners of square side A. Each side is A. We have to find electric field at which one? 4th corner, correct? So let's find electric field at the 4th corner. So electric field at, let's name it electric field. This is our A, B, C, D. We have to find electric field at D, correct? So what will be our field due to the first charge, okay, at D point? Radially outward, right? This is EA. Electric field due to the charge at C, it will be radially outward because positive charge, EC. Electric field due to B, along the line joining and in this direction. I hope this is clear. Okay, great. Let's find the magnitude, okay? So magnitude of EA, that will be KQ upon separation is A square. I hope this is clear. Separation AD is A. So KQ by R square. R is A here. Electric field due to charge C, that will be also KQ upon A square, right? Where A is what? The separation between CD, correct? But be very careful here. B and D, what's the separation between B and D? Root 2A. How do you know that? If this is A and this is A, then using Pythagoras theorem, we can figure out the hypotenuse here. And what will be the hypotenuse? Root 2A. Okay, so in case if you don't know Pythagoras theorem, it is BD square will be equals to BC square plus CD square. Place your values of A here and simplify, you will get the value of BD as root 2A. So let's now find the magnitude EB, that will be equals to K Q upon separation, which is root 2A whole square, and that can be written here as KQ by 2A square. Now these are the values of EA, EB and EC, correct? Once you figure out EA, EB, EC, let's find the resultant of EA and EC. We know EA, so let me remove this Pythagoras theorem here and let's write here EA in this direction and EC is in this direction. And what's the angle between them? 90 degrees. Sir, how do you know it is 90 degree? Because it's a square. So these are the vertically opposite angle. This is 90 and this is 90, right? So they are vertically opposite angles. Okay, great. So if these are 90 degree, what will be the resultant of two vectors having 90 degree between them? R will be equals to root under A square plus B square plus 2AB cos theta, correct? And theta is 90 degrees. So cos 90 is 0. So we left with root under A square plus B square. Now if you look at the magnitude of EA and EC, where it is written here and here, both are equal. So if both A and B are equal, it will be root under A square plus A square, which is 2A square, or the resultant will be root 2A, correct? So let's use this directly, and resultant of electric field, resultant R of EC and EB, resultant means the total effect of EC and EA will be root 2. You can write either EC or EA, both are same, KQ square by KQ by A square, correct? So KQ by A square, this is the resultant. And where do we get the resultant? From 11th standard, I hope you know that it will be along this direction. By parallelogram law of vector addition, this will be the direction of R, okay, inclined 45 degree with each. So we know that this R here, if you want to plot, it will be in this direction. So this is the resultant effect of EC and EA. And that is pointing along EB, right? So what will be the net effect of the whole thing? What is the net force at D? Sorry, electric field at D. So net electric field at D will be EC, EB plus the resultant of both the electric fields. So net electric field EB is how much? KQ by 2A square plus resultant is how much? It is root 2 KQ by A square, correct? Let's take common out here. So KQ by A square taking common, this will give you half plus root 2. I hope this is clear. This is our second one. So ED is KQ by A square half plus our root 2. Clear it is? Okay, great. Let's move to our next one. Question 3 says a charged particle of mass 1 gram. So let's write what is given here. M is equals to 1 gram, 1 into 10 to the power minus 3 I am putting, okay, because it's given in gram. 1 gram suspended through a silk thread of length here of the thread is 40 centimeter. So 40 into 10 to the power minus 2 on a horizontal, in a horizontal electric field, E is equals to 4 into 10 to the power 4. Always write what is given. It will help you to simplify the problem. If the particle stays at a distance of, so distance, let's write it D, 24 centimeter once again, 10 to the power minus 2 meters. Okay, this is meters and this is kgs. Okay, yeah. In equilibrium, find the charge of the particle. Clear? So let's roughly draw a diagram. Okay, so let me draw here. This is our, let's say, ceiling here. Okay, so this is our ceiling. Now, question is saying a charged particle of this much gram is suspended through a thread. So let me draw a thread, okay, and this is, okay, of this in a horizontal electric field. If the particle stays in a stays at a distance of 20 centimeter from the wall. So if this is the distance, let's draw our wall. So this is our wall, let's say. Okay, this is our wall, and from this wall it is 24 centimeter away. So this is our thread, and let's say this is our particle. Okay, let's say this is our particle, and at what distance it is away? 24 centimeter. So this gap is 24 centimeter. Okay, I'm not writing centimeter meter, I'm just writing 24. Okay, we will see, include this 10 to the power minus 2 later. So this is our 24 centimeter. Okay, and this is our mass. Okay, and what is given here, another thing, the length of the thread. So this length of the thread is 40, okay, centimeter. Obviously we will later convert it into 10 to the power minus 2, right? Now let's say this is the angle theta here, which is made with this, right, at this particular place. Let's see what are the different forces which are acting on it, because if it is in equilibrium, we are talking about force, right? Net force is 0, correct? So we are dealing with forces over here. Let's deal with the forces. First force, okay, that is the weight of this particle. And where is the weight of the particle? It will be vertically downward, correct? And how do we write this weight? So let me write here forces. Weight. And what is the value of weight? mg. And where is the direction? Downward, vertically downward, correct? This is mg over here. Okay, great. So if this is mg, and what is the force acting on this particle due to the electric field? Because if there is electric field, we know there is Coulomb's law. Coulomb's law says that the charged particle will be experiencing some, okay, because the question is saying it is charged. If it was no charge on this particle, then in that case we have only weight, right? But if there is a charge on this, okay, then there will be Coulomb's force here, and that will be in which direction? It will be in this direction, repulsive force, right? Why repulsive force? Because of we know that it is horizontal, electric field is horizontal, so there is F force, our Coulomb's force, right? So I'm not writing here, it is horizontal, or let me write here, electric force is there, okay? So electric force, and that is given by F, and where it is? Along horizontal direction, along horizontal direction. Okay. Now how much charge is given? They have not given us, because question itself says find the charge on the particle, right? So we know from Coulomb's law, from Coulomb's law, we know that F equals to QE, correct? The charge on this. Okay, so weight is downward, force is this side. One more force we have learned in class 11 standard, that is tension force, that will be acted up along this thread. So let's write here T, correct? And if I draw a line along this direction, let's say this is a line along this direction, okay, parallel to our wall, then we know that this angle will be theta, right? Alternate angles, because this is vertical and that also vertical. So this will be, this is our vertical direction, that is also vertical direction. So this angle theta will be alternate angle with that, right? So that will be angle theta. So if this is T, what is the component of T along the horizontal direction? T cos theta, correct? Or sin theta? It will be sin theta here. Why? Because theta is made with that thing. So T sin theta here. And there it will be cos theta. Why? Angle with the side is always cos, right? So theta is made here with this axis, so it will be T cos theta, and that will be T sin theta, right? Okay, great. Now let's write our equations. Okay, looking at the diagram, let's write our equation. So first equation is T sin theta is on the right hand side. This is equals to the force F. What is F? QE. And they should be equal. Why? Because they are in equilibrium, right? So net force will be along x-axis, should be cancelled out, right? So T sin theta must be equal to F. This is equation 1. Second equation is T cos theta, which is acting upward. That is equalized by whom? The weight, mg. This is our equation 2. Now if these equations are equal, T sin theta equal to F and T cos theta equal to mg, let's divide equation 1 and 2. On dividing, okay, dividing equation 1 and 2, okay, what will we get? T cancels on the left hand side, sin theta upon cos theta, tan theta on the left hand side, right hand side F upon mg. Let me repeat once again. T and T in this factor cancels out, sin theta upon cos theta is tan theta equal to F by mg, right? F is nothing but, this implies, so tan theta is equals to, F is nothing but QE upon mg. I hope this is clear, right? And we have to find the charge, okay? So Q, let me go from here, this side, Q will be equals to our mg tan theta upon electric field E. Let's see what is given in the question and what are the parameters which are not given. So E is given, mg, g is acceleration due to gravity. Okay, they have specified 10, or you can take 9.8. Okay, and mg is done, and 10 theta. Now you need theta. Okay, so let me go back to the diagram here, and let's see this. Look at this triangle. Which triangle? Let me name it as A, B, C. Okay, this is a triangle, perfect triangle. Okay, where AB is how much? 40 centimeter, 40 into 10 to the power minus 2. And BC, now I am taking here 24 into 10 raised to minus 2, correct? This is AB upon BC, correct? So AB and BC. So what will be tan theta? Tan theta will be how much? Perpendicular upon base, right? So if theta is made here, perpendicular is what? BC upon AC. But sir, AC is not given. But we can find AC, right? How can you find AC? AC we can find using our that thing, Pythagoras theorem, correct? So this will be theta here, and okay, and we can also take sin theta and cos theta also. Okay, so at least we will BC upon AC. So BC is how much? 24, and AC we can find using Pythagoras theorem. So let's find AC. Okay, so let me write here AC square. So AC is equal to root under AB square, which is our 40 into 40, which is 1600, minus BC square, which is 24 into 24. How much it is? 576. Correct? So 1600 minus 576 is equals to 1024. 1024. And 1024 root will be 32. So that is equal to 32. So AC is 32 centimeter. Be very careful. Let me just put it in bracket. AC is 32 into 10 to the power minus 2. Correct? This is our AC. Okay, great. So once we have found our AC, what will be tan theta? BC upon AC. So tan theta is how much? 24 upon 32. Okay. So let's find the value of Q. It is equals to M. M is 1 into 10 to the power minus 3. G 9.8. Tan theta. Just now we found, once again I am repeating, BC is perpendicular, 24 upon 32. Centimeter part will cancel out. 24 upon 32. 10 to the power minus 2 will cancel out. Electric field, how much given in the question? 4 into 10 to the power 4. So 4 into 10 to the power 4. Correct? Let's simplify this. So 1 into 9.8, that's 9.8 into 24. Okay, is 235.2 divided by 4. 58.8 divided by 32. That will give you 1.8, and into 10 to the power minus 4 goes up, minus 7. And what's the unit of charge? Coulombs. That's our answer to this particular problem. Okay. Let's move to fourth question. Question number 4 says, a particle having a charge of 5 into 10 to the power minus 7 coulomb. It is fixed in a vertical wall. Okay. A second particle B of mass. Okay, let's write what is given first. So question says the particle A has charge. So let me write here QA, that is equals to 5 into 10 to the power minus 7 coulomb. It is fixed in a vertical wall. We will see the diagram later on. We will make a diagram later on. A second particle B of mass. So mass of B particle is given here as 100 grams. So let me convert here only 10 to the power minus 3 kgs, right? Having equal charge. Equal charge means QB and QA. So I am just writing here only it is equal to QB, correct? Is suspended by a silk thread of length. Length of the thread is 30 centimeter. Okay, from the wall. The point of suspension, okay, is 30 centimeter above the particle A. Okay, fine. Point of suspension is, okay, 30 centimeter above the particle A. Okay, so let's try to draw the diagram. Let's say this is our any particle A. Pay attention on the diagram because it will help you to understand the question in a better way. If this is any point A, okay, where the particle A is placed, right? Okay, and charge is how much? 5 into 10 to the power minus 7 at this point. From here, okay, the question is saying the point of suspension is 30 centimeter above the particle A. So from here, let's say this is the point of suspension. Okay, here this is how much separation. I'll explain this once again once the diagram is complete. Okay, this is our 30 centimeter. I'm writing for the time being centimeter only. Later we will convert it into the standard units. Okay. So this is any point P. This point P is the point of suspension, right? Okay. Let's now read the question once again. A particle A having a charge of this much is fixed in a vertical wall. So this is our vertical wall, right? Okay, vertical wall. Any wall. Imagine any wall in your room. Second particle B of mass 100 grams and having equal charge is suspended by a silk thread by a length of 30 centimeter. Silk thread of a length 30 centimeters, which is any point here. Okay, and this is our B, let's say. This is our particle B. And what's this length of this thread? 30 centimeter. From the wall. 30 centimeter from this wall. The point of suspension is 30 centimeter about. So this is our point of suspension, right? Okay. Now what is this angle? This angle, let's assume this is angle theta. Correct? Okay, great. If this is angle theta, this is particle B. Okay. So let's see what are the forces. Okay, let me just make it a little above so that we can understand it better. Okay, here. So, okay, here it is. So B here. Okay. So this is our any particle. Okay, B. Suspended here. Now what are the forces acting on B? Let's see. Okay. Question says find the angle of the thread with the vertical when it stays in equilibrium. Equilibrium means net force is 0. You have to find the angle theta. Correct. So B, let's see what are the forces acting on B. First of all, weight which is acting downward. Parallel to AP. Okay. And this weight will be parallel to AP, mg. Downward here. Correct. Okay. This is the first force. Second force is tension. We have just now seen in the previous questions. So tension. We know that if there is a thread which is like this, then there will be a tension along this direction, T. Correct? Second force. Third is electric force or electrostatic force, which is our in this direction along the line joining. So let me write here, this is force. Which force? F, electric force. These are the forces acting on this. Correct? Okay. Okay, great. So if this is our, okay, theta, this is 30 centimeter, this is 30. Okay. Now let's say first of all, okay, theta, okay, and if AP is equals to PB, if AP is equals to PB, then this angle will be equals to this angle. Okay. Let's say these two angles are angle X. Correct. So let's start with the very basic concepts of triangle. Triangle PAB. PAB. Correct. If triangle is PAB, in this one, what will be our angle sum property? Theta plus X is equals to 180. Sir, why you took both of them as X? Because PA is equals to PB. Angle opposite to equal sides are equal. So, right, both will be equal. So, what will be X? 2X is equals to 180 minus theta. And X will be 90 minus theta by 2. I hope this is clear. Okay. So our X angle is, this is our very important thing. Okay. So I'm just writing, instead of writing here X, I am writing here 90 minus theta by 2. 90, both the angles, theta by 2. This will be 90 minus theta by 2. Correct. Now let's imagine or let's draw a straight line anywhere. Okay. Such that PB is perpendicular to that. So imagine this line, this line is, we are drawing, we are constructing, okay, a line. Let's call it as XY, capital XY. Okay. This XY is a line which is perpendicular to PB, which means this angle is how much? This is our 90 degree. Correct. So if this is 90 degree, now this is construction. We can imagine such a line, okay, because we will get a line in such a way that PB will be perpendicular to that line. So XY, PB is perpendicular, so that is 90. Now if that is 90 and this is 90 minus theta by 2, what can you say about this angle? Obviously, this will be theta by 2, right? This angle will be theta by 2. How? See, in a linear pair, the sum of this angle, 90 degree, or let me write it for you simply here, 90 degree plus 90 minus theta by 2, okay, plus theta by 2. Then only it will give you 180, right? Because theta by 2 will cancel out. Or you can call it as y and evaluate it, you will get theta by 2. Correct? Let me repeat again. This whole angle over here, this is 180 degree. So if this is 90 and that is 90 minus theta by 2, then this must be theta by 2. And if this is theta by 2, then be very careful. This angle will be also theta by 2, that is vertically opposite angles. I hope this is clear. Okay, angles are very important here. Then only we can understand our basic concepts. Great. So we are done with the angles now. Okay, so we are done with the angles. Now let's go concentrate on our forces. Okay, why? Because the question is saying find the angle of the thread for which it is in equilibrium. So which angle you have to find? Theta. That's our very important part. So we have to find theta for which this is in equilibrium. So we have considered all the angles. Now we will focus on forces, because the other part of the question is saying equilibrium. Equilibrium means force equilibrium, right? So first of all, let's take our components here. Okay, so what's the component of this force along this x-axis? Okay, bx. Okay, so first of all, let's see the component of force F along bx. Let me remind you once again, the component will be F cos theta by 2. Let me repeat again, component of this force F along x, this bx will be F cos theta by 2, correct? And what will be the component of mg? Okay, see, mg, it is vertically downward, right? So if it is vertically downward, then our angle here will be how much? Let's find this angle also. Okay, so if this is theta by 2 and this is vertically downward, then this will be 90 minus theta. Why it will be 90 minus theta? Because if I draw here like this, okay, then we know that this angle theta and this theta will be what? Our corresponding angles, right? And if it is corresponding angles, okay, then you can add 90 minus theta by 2 and theta by 2 and theta, okay, and 90 minus theta, this will give you 180. Let me repeat again. If we construct, if we join here this P to B to, let's say, Y, or Y we have already taken, so let's say T. So this PT, along this line PT, we know that this angle theta will be corresponding angle to this theta, and that's make it 90 minus theta, right? So our F cos theta by 2, this must be equal to our component. Which one? Along, if F cos, where is F cos theta by 2? It will be along this direction, right? This must be equal to the component of mg along y. So what is that? Mg cos 90 minus theta, correct? Okay. Now what is mg cos 90 minus theta? We know that cos 90 minus theta is sin theta. So it will be mg sin theta, correct? And that is F cos theta by 2. Now sin theta, mg sin theta is nothing but, let's use half angle formula, 2 sin theta by 2 cos theta by 2, correct? That is F cos theta by 2. I hope this is clear. Now let's cancel out cos theta by 2 both the sides. So cancelling out cos theta by 2 both the sides, we will be left with F equals to 2mg sin theta by 2. Correct? So this is our main equation number 1. Okay, we will put here the values later on, but let's find first what is the force. Okay, so let's figure out our force. So force, magnitude of force will be, I am writing here, so electric force F between the two charges will be K, which is our constant, Coulomb's constant, into Q1 Q2 upon separation R. This is our Coulomb's law. So what is our K value here? K value here is 9 into 10 to the power 9. Charge, what is the charge on A? That is 5 into 10 to the power minus 7. Charge on B, same as charge on A, 5 into 10 to the power minus 7. And what's the separation? Separation is, sir, AB. Okay. Do we have AB? No. So we will have to first find AB. Clear? So AB we can find by using our law of cosines from triangles. Okay. What is law of cosines? Let me do it here. Okay. So that I'll erase later on. So first of all, if you're given with any triangle here, okay, with this angle theta, and this is our C, this is A, this is B. Pay attention. C square will be always equals to A square plus B square, okay, minus 2AB cos theta. Correct? Okay. Now, if A and B are equal, like in this situation, our AP and PB are equal, 30 centimeter each. Okay. So if A and B are equal, this will become 2A square minus 2A square cos theta. Correct. And this will give you 2A square common out, 1 minus cos theta. correct? And 1 minus cos theta is nothing but 2a square into 2 sine square theta by 2, correct? Half angle formula. So this will give you 4a square sine square theta by 2, correct? That is our c square, or c will be equals to root of this thing, which is nothing but 2a sine theta by 2, okay? So from there we can simply use this angle formula, okay, law of cosines. In case if you don't know or you have not understood, go through it once again, okay? So I'm removing this. We will directly use here. This is law of cosines for triangles, okay? So let's see. When do we use law of cosines? If one angle and two sides are given. So what we got from law of cosines, okay, this is our equation 2. Let's figure out our AB. So AB will be equals to nothing but 2 times, okay, 2 times AP, let's write AP sine theta by 2, okay? AP is 30 centimeter, correct? So let me write here 2 into 30, or let me directly put it there, or 2 into 30 into 10 to the power minus 2 into sine theta by 2, correct? This will be your value, okay? Now let's substitute in F. So F will become equals to 9 into 10 to the power 9 into 5 into 10 to the power minus 7 into 5 into 10 to the power minus 7 whole divided by AB, which is how much? 60 into 10 to the power minus 2 into sine theta by 2, correct? Now let's substitute it here in equation 1, okay? So if you substitute here, what is our F? F will be equals to, so we can cross multiply here. Now, okay, let's substitute only, then we will simplify. 9 into 10 to the power 9 into 5 5 is 25 into 10 to the power minus 14 whole divided by 60. So 6 into 10 to the power minus 1 into sine theta, correct, by 2 equals to 2 mg. What's the weight? M, mass of the object. M is given as 100. So 100, 2 into 100 grams, so 10 to the power minus 3 into 9.8 into sine theta by 2. I hope this is clear, okay? I have done a small mistake here. It's AB square over here, right? So here it will be, when you'll put here, it will be square of this whole thing, correct? So this will become square over here, okay? Because F is equals to K Q1 Q2 by R square, okay? So this will be square, and when you expand it, it will give you 9 into 10 to the power 9 into 25 into 10 to the power minus 14 whole divided by 636 into 10 to the power minus 2 into sine square theta by 2 equals to 200, or let's remove the zeros, 2 into 10 to the power minus 1 into 9.8 into sine theta by 2, correct? So let's take everything on the other side. So it will become sine cube theta, okay? Let me use a different color so that we can highlight our angle. So sine cube theta by 2, that will be equals to how much? Let's cross multiply. So this will be 9 into 10 to the power 9 into 25 into 10 to the power minus 14 whole divided by 36 into 272 into 10 to the power minus 3 into 9.8, okay? And when you simplify it, okay, you will get approximately sine cube theta by 2 is equals to 0.0032, and using a calculator you can figure out our angle theta, which is equals to nearly 17 degree. That's our complete answer. I hope this is clear. So fifth says, 4 particles each having a charge q are placed at the 4 vertices of a regular pentagon. The distance of each corner from the center is a. Find the electric field at the center of the pentagon. So let's draw a regular pentagon. So let's say this is our pentagon here. Pentagon means a closed figure with 5 sides, okay? Pentagon is 5 sides, right? Okay, and let's say here we have a charge q, charge q, charge q, and charge q here, right? Okay, and due to these 4 charges we have to find the field at O. Okay, now see here, what is important thing about these closed figures is, if you have the 5th charge, then what will be the field at the center? 0. Let me repeat it again. If you place a 5th charge again, what is the electric field at the center due to all the charges? 0, which means the sum of these 4 must be equal to the field of 5th one. Let me repeat again. If you are placing here a 5th charge here, then the resultant electric field at the center O is 0, which means the sum of all other 4 must be equal to our fifth one. So electric field of all the four, E4, okay, for the charges E, let's call it as A, B, C, D, then EA plus EB plus EC plus ED must be equals to the electric field due to the fifth charge. Let's imagine that fifth charge also Q, and it is at the separation of A. So E, okay, let's call it as E point, EE. So what is our EE? This will be equals to 1 by 4 pi epsilon naught Q by A square. Our fifth charge electric field must be equal to the sum of all other four charges. If they are, then only the resultant reduces to 0. I hope this is clear. This is our fifth one. Let's move to the sixth question. Question 6 says, find the electric field at any point P on the perpendicular bisector of a uniformly charged rod. Okay. The length of the rod is L, the charge on it is Q, and the distance of the distance of P from the center of rod is A. Okay, great. Let's imagine a rod. Okay. So let's say this is our rod over here. Okay. So let's make a small rod here. Okay. So this is a rod, correct? And what we are having, given quantities, find the electric field at point P on the perpendicular bisector. Perpendicular bisector means it is splitting, it is perpendicular and splitting the rod into two equal parts. Okay. So at any point P we are looking for. Okay. And this is at a distance of A, and rod is of length L, correct? So if it is equally splitting, okay, so this will be L by 2, L by 2. So this is L, correct? This is L, and this will be L by 2, and this is L by 2. Okay, great. Now let's imagine a small element. Small element means a small part of this rod. What is the length of the small part? Dx, which we will integrate to get the whole rod, right, later on. And let's say this is the center O, and from O this is at a distance of x. Great. So what will be, assuming that there is positive charge all over this rod, then what will be the electric field due to this dx element? It will be radially outward. So let's join this point and dx. And radially outward in which direction? In this direction. So this will be our dE, because it's not the complete electric field. It will be dE, correct? And if we elongate this side, this will make an angle theta here, correct? Okay. And what will be the component of dE along this line? It will be dE cos theta, right? So this is our figure. Let me repeat again the whole figure. We have a rod here with all positive charge all over it. Okay, you can take negative and make this dE downward, and you can do the same thing, right? So it is all positive charge. A small element, a length element is dx. The length of this whole rod is L, and this length element is at a distance of x from it. Point P is the point at which we are finding the electric field, okay? And that is at a distance of A from this. Great. Now first thing, if it is uniformly charged, for a uniformly charged rod, what is constant? Linear charge density. Linear charge density. What is linear charge density? Lambda, which is equals to Q by L, correct? Okay, great. So if lambda is Q by L, which is fixed for this whole thing, sir, what is the lambda and how do you explain this? Okay, so see here, if you have a rod like this, okay, let's say this is a small part of wire, this is another part of wire, and this is much more smaller. Then what does lambda says? Lambda says that 5 by 10, I'm just taking an example, then I will explain you, 6 by 12, 50 by 100, or 100 by 200. Each segment of this wire will have lambda equal. How? 5 by 10, half, 6 by 12, half, 50 by 100, half, 100 by 200, half. The ratio of charge per unit length remains constant. Though each section has a different Q value, numerator is different. Each section has a different length value, denominator is different, but overall ratio remains fixed for a given wire, correct? Okay. So lambda for this whole wire remains same, correct? So if lambda remains constant, can we find what will be our charge present in this dx? So charge present in dx will be dq, which is equals to lambda into dx, correct? And what is lambda? Q by L. So Q by L into dx. Charge per unit, the length of the whole rod equal to dq. This is the charge present in that region. If this is the charge present, due to that small charge which is present in dx, what will be the electric field? It's a dE, that is equals to k, which is 1 by 4 pi epsilon naught. Charge q, what is charge q? dq upon separation square. What's the separation? So let's call this point is as any point, let's say s, sp square. Great. Now what is sp square? That we have to find. Clear? So here this will be our electric field, equation number 1. Clear? So what will be the electric field along this direction? dE cos theta, correct? Because see here, dE cos theta in this direction and dE sin theta in direction. But if you imagine this small length element on the left hand side, then all the dE sin thetas will cancel out. Why? Because dE sin theta here will be in this direction and cos theta will be upside. So all the cos thetas will add up and sin thetas will cancel out here. Correct? So resultant electric field will be dE cos theta. Correct? And dE cos theta will be equals to dq upon 4 pi epsilon naught sp square. And what is cos theta? Cos theta will be, if this is angle theta, this will be angle theta. And if this is angle theta, from here, what will be the cos theta? Cos theta will be base, which is OP upon hypotenuse SP. Correct? OP upon SP. So let's write here OP upon SP. I hope this is clear. Now let's substitute the values. So first of all, dq as it is upon 4 pi epsilon naught. And what is SP square? Look at this triangle. SP square is A square plus x square. SP square is equals to OP square plus OS square. And what is OP? A square and OS x square. Correct? So this SP square, SP cube, it will become. So let's make it as SP is equals to how much? Root under A square plus x square. And SP cube will be equals to A square plus x square whole power 3 by 2. Correct? So A square plus x square whole power 3 by 2. In the numerator we left with OP. What is OP? OP is angle, side A. So dq into A it is. I hope this is clear. Okay. This will be our value. Okay. A. Okay. That will be our OP. So dE cos theta, that will give you here. And what is dq? dq is nothing but q by L into dx. From which equation? This equation over here. So let's substitute that also in the next step. So this will be A upon 4 pi epsilon naught A square plus x square 3 power 3 by 2. And what is our dq? Let me go up, q by L into dx. So let's write q by L into dx. Now we got our in integral form. We can integrate it with respect to x on the right hand side. Clear? And what will be the limits here? Limits will go from minus L by 2, because here we will assume that this is origin, minus L by 2 to plus L by 2. You can also make it from 0 to L. Okay. So that won't alter the result. So let's write it here. Let me make a straight line here and start deriving after this. Okay. So this will be here dE cos theta. Electric field will be, the net electric field due to this rod will be dE cos theta integration. And that will be integration of let's take the common outside. So that will be A is coming out, Q is coming out upon 4 pi epsilon naught, that is constant. Length of the rod is also constant, fixed, minus L by 2 to L by 2 dx upon A square plus x square whole power 3 by 2. Now you need a little bit of integration here. So if you have A square plus x square, what you can take? You can assume substitution method. What we will do? We will assume x is equals to A tan theta. Okay. And if x is A tan theta, what will be dx? Dx will be A sec square theta d theta. Correct? And if it is so, then we can convert this whole thing into our substitution part, that is equals to AQ, okay, whole divided by 4 pi epsilon naught, okay, and minus L by, but limits also change, no? So let's simplify this, evaluate this in a simple manner, and then we will put it back to our problem. Okay. So what we will do here is our integration of dx upon a square plus x square whole power 3 by 2. Okay, let's solve this separately. This will be, what is dx? A sec square theta, right? So a sec square theta d by d theta upon what is our this a square plus x square? A square plus x square, that we can write it here as, what is x? A tan theta. So when you write it, you will get here a square plus a square at tan square theta, right? X square. And when you take a square common, you will get 1 plus tan square theta, which is sec square theta. So I am writing here a cube sec cube theta. From where I got? Because cube is there, 3 by 2. Okay, let me roughly explain once again. This a square plus x square, right? So here it will be a square plus a square. What is x? X is a tan theta. So a square tan square theta, correct? Now if I take a square common, it will be 1 plus tan square theta. And 1 plus tan square theta is nothing but sec square theta, correct? And whole power is how much? 3 by 2. So this square and 2 will cancel out and cube will be there, right? So a cube sec cube theta. Let me remove this whole thing. Okay. Now, so this, when you integrate, before you integrate, everything will cancel out. A and a cube and a, this will cancel out. Sec square and sec will cancel out. You left with integration of 1 by a square, which is constant outside, and integration sec square upon 1 by sec, which is cos theta d theta. What is cos theta? Integration sin theta, right? 1 by a square sin theta, correct? And sin theta, okay, you have to find. What is our tan theta? Tan theta is x by a. Okay, this is our final result, okay, of this integral. But we don't know what is sin theta. So first we will do what? We will find sin theta. How do you find sin theta? So let me remove this whole thing, okay. We have already found our integral. So this integral is giving us 1 by a square sin theta. 1 by a square sin theta. Sir, how do you convert this sin theta into the given known values? So see here, from this part, tan theta is nothing but x by a, correct? If tan theta is x by a, okay, so perpendicular is x and base is a. Hypotenuse will be how much? Root under x square plus a square, right? Okay. So what will be corresponding sin theta? Sin theta will be perpendicular our x upon root under x square plus a square, correct? So let's substitute this value to this part. So this will give you the correct answer. Here will be integration will be of this whole thing. Let me remove this whole thing and let's write here. This will give us aq upon 4 pi epsilon naught L. Okay. And what's the integration of this part gives us? Integration of this part gives you 1 by a square. And sin theta. Sin theta, what we evaluated? X upon x square plus a square. Okay, whole power half, which is root. Okay, and what's the limits? Minus L by 2 to L by 2, correct? Okay, now let's put the final limits. So this will give you outside. So 2aq, this a and one of the a will cancel out. We can cancel them. So you're left with q upon 4 pi epsilon naught L a, and here putting the upper limit, it will be L by 2. Okay, that you can put here upper limit L by 2 upon L by 2 whole square plus a square whole power half, okay, minus putting the lower limit L by 2 minus L by 2 will make it plus L by 2 whole divided by squaring it again L by 2 whole square, minus will give you plus only, plus a square half, right? So when you simplify this expression, okay, when you put the upper limit and lower limit, what will you get finally? Q by 4 pi epsilon naught a into L, okay, and even L will be in the top, L into 2 whole divided by, you will get root under L square plus 4a square, okay, and finally you can get it as q upon 2 pi epsilon naught a root under L square plus 4a square. Great. So this was our electric field at the perpendicular part. Our question number 7 says a uniform electric field E is created between two parallel charged plates as shown in the figure. An electron enters the field symmetrically between the plates with speed v0. The length of each plate is L. Find the angle of deviation of the path of the electron as it comes out of the field. So basically what is happening here, let's understand the situation. Okay. So here what we have is, we have a particle. Which particle? We have an electron. So our electron is entering here, okay, in this direction with velocity v0, right? And these are the two plates, okay, any conducting plates, okay, having some charge positive and here negative. So what will be the direction of electric field? It will be downward here, radially away from positive charge and towards the negative charge, right? Because of this electric field, okay, so when it is traveling from here to here, it will not experience any force, right? But moment it enters this field, it will experience a force. What kind of force? Electric force. And what's the value of that electric force? F equals to QE. We will go into that. But let's understand the situation. What if there was no conductors? There was no conductor here. If there was no conductor, this electron was supposed to go in this direction, right? Straight away, horizontal direction along x-axis. But because of this force which is experienced by the electron due to this electric field, it will, instead of going straight, it will go slightly upward. So it has a y component also. Along with x component, it will have a y component also. Let's figure out what is the y component. So what's the velocity along y-axis? Velocity along y-axis will be, we will find it, right? So that we will find, that will help us to understand this angle theta. So first of all, let's see what is the force experienced by this electron. So we know that the force is nothing but mass times acceleration. And this force is nothing but our electric force, which is Q into E. Let me repeat again. The electric force experienced by the electron will be QE, and because of this force, there will be mass times acceleration. Okay. What is mass? Mass of the electron is ME, correct? So acceleration produced in the electron will be QE by ME. This is the acceleration, right? And we know from equations of motion. So from equations of motion, which equation? Let's see. V equals to Vy equals to U, okay, Y plus A T, correct? Now be very careful, this acceleration is along y-axis, no acceleration along x-axis because there is no other force, right? So I am writing here Ay, and this is our acceleration Ay only, okay? From equation 1 we will get acceleration along y-axis. What is our initial velocity along y-axis? 0, right? Because the electron was projected along x-axis. So there is no y component. So Vy will be equals to Ay into T, correct? And what is Ay? We just now found Q. Q is nothing but E, charge of electron, E upon mass of electron into time T. That's our Vy. That is our equation number 2. Now we know that how much time it will take for the electron to go between these plates, okay, which is from this point to this point, okay. How much time it will take? Time is equals to distance upon speed, right? L upon V0, initial velocity with which it is projected. So this is our equation number 3. Let's substitute here. So this Vy will be equals to how much? E by ME, and time is how much? Length upon speed V0. This is our equation number 4, correct? Now this is our velocity Vy, okay? What's our velocity along x-axis? So velocity along x-axis is V0, Vx is V0, okay? So theta we can find at any point. Theta is nothing but Vx and Vy. This is Vy. So theta, tan theta will be the ratio of both, that we know from projectile motion also, last year 11th standard. So this tan theta is nothing but Vy upon Vx, correct? The ratio of velocity along y-axis and x-axis. So when you divide both, it will, what is Vx? Vx is V0. So this expression will take the form EEL upon what it is? M V0 square. Why V0 square? Because Vx is also V0. So theta, the deviation will be nothing but tan, taking on the other side tan inverse EEL upon MV0 square, okay? This is our theta. Done. Let's move to our next question. So question 8 says, in a circuit, 10 coulomb of charge is passed through a battery in a given time. So Q here is 10 coulombs. The plates of the battery are maintained at a potential V equal to 12 volt. How much work is done by the battery? So we know that Q and if work done is nothing but potential energy stored in the system. So that is charge into potential. So charge is how much? 10, and V is how much? 12. It will be 120 joules, right? Done. This was our 8th one.
Let's move to question number 9. Question number 9 says there are two charges, 2 into 10 to the power minus 6 coulomb and 1 into 10 to the power minus 6 coulombs. Okay, they are placed at the corners of A and B of a square of side 5 cm as shown in the figure. How much work will be done against the electric field in moving a charge of 1 into 10 to the power minus 6 from C to D? Correct. And to figure it out, we have to find the potentials first at C, potentials at D, and then you can multiply the charge with the potential. So let me give you a brief idea of how to evaluate this. First, let's understand here that there is a charge here placed Q1 and another charge placed here Q2. And since they are placed here at point C, there is nothing, but there will be potential due to both the charge. At D also there will be potential due to both the charge, right? And if you are taking from C to D, we will take the potential difference between D to C. Okay. So first of all, let's take the overview of work done. Work done will be here charge into potential VD minus VC, correct? Potential at D minus C, this we know. Okay, so charge into potential difference, that is the amount of work done, correct? First, let's calculate VC, potential at C. So VC will be equals to K. I'm just writing here K, later we will substitute it as 1 by 4 pi epsilon naught K. And what's the charge? Q1 upon our AC plus Q2 upon BC. This is the potential at C due to both the charges, right? So let's see if there is something common. No. Okay, this is square of 5 cm, this is also 5. So what will be AC? AC will be our root under 2 root under 5 square plus 5 square. So using Pythagoras theorem, 25 root 50 it will be, right? So root under 50. Okay, so let me write here, this is root 50 by using Pythagoras theorem. Okay, so Q1 is how much? 2 into, so let me write here 9 into 10 to the power 9. Q1 is nothing but 2 into 10 to the power minus 6 upon AC, which is root 50, and then it is plus Q2. Q2 is how much? 1 into 10 to the power minus 6 whole divided by BC, which is 5, right? Let's simplify it further, and this is in centimeters. Be very careful. So let me take here 10 to the power minus 2 common, correct? So this will give us 9 into 10 to the power 11, okay, and 10 to the power minus 6 also common. So this will be 2 upon root 50. Root 50 is 2 root 5 plus 1 by 5, correct? Okay, so this will give you 9 into 10 to the power 11 minus 6, 5, and 1 by root 5 plus 1 by 5. Okay, this is our VC, equation number 1. Let's find VD, potential at D, okay, due to both the charges. That will be K Q1 upon, what's the separation? AD. AD will be 5, so Q1 upon AD plus Q2 upon BD, correct? So let's put here K is 9 into 10 to the power 9, and Q1, what's Q1? Q1 here is 2 into 10 to the power minus 6 whole divided by AD, which is 5, and let's take centimeter outside only, 10 to the power minus 2, okay, plus what's our second charge? Q2, 1 into 10 to the power minus 6, and this time BD, you can see that's the diagonal, so root 50 once again. Let's simplify it. It will be 9 into 10 to the power 11, and taking 10 to the power minus 6 outside, this will give you 1 by 5 plus 1 by 2 root 5, correct? And sorry, 2 here is there, not 1, so this will be 2. Okay, now this will be 9 into 10 to the power 11 minus 6, which is 5, 2 by 5 plus 1 by 2 root 5, correct? This will be our VD. This is our equation number 2. Now we got the potential difference, we got the VD and VC. Now let's do, okay, apply these two in this equation, okay, that is work done equals to charge, and which charge this time? 1 into 10 to the power minus 6. This charge we are taking along CD, so we are going from C to D, so potential difference will be from D to C, right? So here let me write first, work done will be equals to charge. What is the charge here? 1 into 10 to the power minus 6 into VD minus VC. VD is 9 into 10 to the power 5, 2 by 5 plus 1 by 2 root 5 minus Vc. Let's go to equation 1, which is 9 into 10 to the power 5, 1 by root 5 plus 1 by 5, correct? This is our final equation which you have to solve. So first of all, take 9 into 10 raised to 5 common out, so it will be 9, and 10 to power minus 6 and 10 to power plus 5, 10 to power minus 1. What we left with in bracket here? 2 by 5 plus 1 by 2 root 5. What we left there? Minus 1 by root 5 and minus 1 by 5, correct? Let's simplify it further. On simplifying, we will get here 9 into 10 to power minus 1, 0.9 into 2 by 5 minus 1 by 5, first and the last term, 1 by 5, and 1 by 2 root 5 minus 1 by root 5, this will be plus 1 by root 5, correct? This we left with. So we can further simplify this, okay? Let's see. So let me directly do here. 1 by 5 is 0.2, correct? So let's first find 1 by root 5. So root 5 is nothing but 1.49. So 1.49, 1 divided by 1.49 is nothing but 0.67. So let me write here, work done will be equals to 0.9 into 0.2 plus 0.67. Okay, so let's add them. 0.67 plus 0.2, that will be 0.87 into 0.9. So our answer is approximately 0.78, okay, joules. This is our answer to this particular problem.